Hello and welcome to video 2 of 3 parts for section 6.6, which is law of cosines. In this video we're going to look at one very specific use of the law of cosines, and that's the following: navigation problems, or sometimes you'll hear them referred to as heading and bearing. So you'll have a problem like this on your exams in here. You'll very likely have a problem like this on your final exam. We have the following. So in navigation, a direction is often given as a bearing. That is, so what is a bearing? It's an acute angle, or an acute angle measured from due north or due south. So, for example, i.e., if I am given information like the following, it will look like the following notation: N 30 degrees E. What this means, this is a bearing, this is a heading, it means I'm going to start out pointing north. Then I'm going to move that measurement, so in this case 30 degrees, towards the last direction, E. So that means if I had my XY plane here, so let me put this on here too, because sometimes this confuses people. So north is directly up, south is directly down, east is to the right, west is to the left. If you have trouble with this, think of it like the United States. So to the north, what do we have? Canada. To the south, what do we have of us? Mexico. What's over to the east? New York City. What's over to the west? LA. So if you're looking at a map of the United States and you're like, man, I never can get these directions right. Well, think: Canada, north. Mexico, south. New York to the east. Los Angeles to the west. So if we have that diagram, and we're talking about north 30 degrees east. So we're going to start going north, start pointing upwards, and then I want to move 30 degrees from that line over towards the east, which would be the right. So go north, start fading 30 degrees over towards the east, which would give me something like that. So this angle in here would be 30 degrees. North, move 30 degrees towards the east. That's my heading. So if a plane was taking off from an airport and its heading was north 30 degrees east, it means it would be heading in this direction here of the red line. Okay, so super important concept. If any of this is a little bit confusing, office hours, ask me before class, ask me at the start of class. If you don't have this down, I guarantee you this is going to cost you a bunch of points on the exams, because I see it all the time. People think, oh, 30 degrees east, so I'm supposed to be this way going up towards the north. And then they give me a line like this, which obviously is not north 30 degrees east. So just be careful with that. All right, so let's look at a problem. So we're given the following. A pilot heads north 20 degrees east for 200 miles. He makes a correction so why is it a he and why is it a correction? Well, we all know what? Men are terrible at directions. They don't want to ask for directions, but he eventually figures it out. He's going the wrong way, so he makes a correction to his heading and heads north 40 degrees east for 100 miles. Before landing. So given this problem, we want to know two pieces of information. The first one is find the distance between takeoff and landing and second, find the bearing from takeoff to landing. So this second question is basically saying, if he didn't originally head the wrong way, if he would have just went from the airport to the airport in a direct line, what would that bearing have been? So, I'm going to erase the basis of the problem here. Well, let's see. Now, I'll draw the picture down here so we have it. We can refer back to this information. And then once we start working it, then I can maybe erase this part here. So, let's look at what is going on here. So let's give ourselves this XY plane. So the pilot originally is going north 20 degrees east for 200 miles. So let me see if I can grab another color marker here. All right, so I'm going to switch to green for this part here. So his original heading is north 20 degrees east for 200 miles. So he takes off from the airport, goes north 20 degrees east. So like we just saw in that last example, we're going to be going north and then fade a little bit to the east. So originally he starts out like this and gets to this point here. And we know that north 20 degrees east means that this angle inside here between the blue line and the green would be 20. At this point, he realizes, oops, I screwed up. I should have actually been heading a little more to the right. So he changes his course. And so actually let me put on here that the length of this one is what? It's 200 miles. Right on the outside here. So north 20 degrees east for 200 miles. At this point, it's essentially as if he's starting a new trip. So what I'm going to do is here just kind of draw in another little XY axis. Because at this point he goes north 40 degrees east. From here at the end of this green dot, so north and now 40 degrees over to the east. So going this way here, and he went how far? Well, he went 100 miles And again, because it's north 40 degrees east, that means that in here, our value would be 40. So then what we want to know is two things. We want to know this portion here, so this blue line, how far is he from start to finish? And then we also want to know if he would have just headed this way originally, what would this angle be right in there? So what do we have? We have two sides, and we have an angle that we can figure out. So how can we do that? Well, if we go back to geometry, if we have two parallel lines, which is this line here and this line here, if a line cuts through them, the angles on opposite are the same, which means that this angle in here would be 20 degrees, this tiny little slice down between that green and blue. The other way you could do it is if I draw this straight across, what do I get? I get a 90-degree angle here. So I know that the angles inside this green triangle have to be what? 180. So 90 plus 20 is 110, which means this angle right here would be 70. And because that's also a 90-degree angle, 90 minus 70 again gives me 20 as that angle. The same idea holds here, so this angle is a right angle, meaning 90 degrees, and I'm given that the red line is 40, which means that this one here is 50. I'm trying to find this angle between the red and green so that I can use my law of cosines. Again, as I said, this is a big problem for law of cosines. And so then lastly, this is a 90-degree angle between those two, which is a right angle, so 90 degrees. So let me switch to black now. So the black would be this entire angle between red and green. And so that's 50 plus 90 plus 20. So if I add those up, it's 140 plus 20 is 160 degrees, is that black angle between the red and the green. So I'm going to go ahead now. I took the information off the problem, put it in the picture. So I'm going to erase this so I have some room to do my calculations. So let's call this blue line A, or you can call it X if you want. But we're trying to find that length. That's question number one. So using law of cosines, what do we get? We get A squared, and be careful here now. We'll get an answer at the end, and I'll ask you if it makes sense and a problem that people will end up running into. So A squared is equal to what? 200 squared plus 100 squared minus 2 times 100 times 200 times cosine of this angle, which we figured out to be 160 degrees. So therefore, if you do all these calculations on your calculator, put in 160, hit cosine, multiply this all out, add 100 squared, add 200 squared, you get 87587.50. I see a lot of people just stop at that point and say, there's my answer, it's that many miles. Does that make sense? Does it make sense that he could go 200 miles and then 100 miles and end up 87,000 miles away from his start? No. And why is that? It's because of this A squared. So I would highly recommend on these problems, keep bringing this down so that you don't make the mistake where you get to this point and say, oh, this is my answer. No, because A squared, the length of that side squared is 87,000. If we take square root of both sides, the length of side A is roughly 295.95 miles, which makes a lot more sense. He flew 200 miles and then 100 miles, but he changed course, so he's about 295 miles away from where he started. All right, that was the answer for number 1. Now we need number 2, which is a little bit trickier because we're trying to find again his heading if he just took off and landed at that point. So we need this value in here. We have this angle, the black is 160. This side we just figured out to be 295.95. If I have this triangle, so I'm going to redraw it just to clean it up a little bit so we can see what we have. So what do we have? We have a side here, a side here. This one is 200. This one is 100. We just figured this out to be 295.95. And this angle in here is 160 degrees. So I have an angle and a side. I need this angle down here. So what can I use? I can use law of sines. But I have to be careful because this angle down here is really what? It's just this little piece of the triangle down there. So the answer I get right now is not going to be my heading from bearing to takeoff. I'll have to add in this extra 20 degrees because I realistically have, if this line was coming up here, 20 degrees before I have this black triangle, which is the information I'm given. So I can find out this angle, but then I just have to remember I got to add this 20 at the end to it. So let's do this. Let's set this up. So I get what? So this was part 1. So part 2, I get what? Sine of 160 over its opposite side, 295.95, is equal to the sine of this angle, let's call it x, over its length. So the length opposite this one is this side here, the 100. So if I multiply both sides by 100, I end up with sine of x is equal to 100 times sine of 160 over 295.95. So if I calculate this, do inverse sine, I get that x is approximately 6.636 degrees. So that's this portion right here is 6.636 degrees. But that's not my heading from takeoff to landing. I need to add this other 20 so that essentially this green line, if this was my coordinate system, this green line has a heading of this entire piece, which is, if I add 20, so it's 26.636, but how do I write that as a heading? Well, it's north 26.636 degrees towards the east. So the answer for part 2 would be north 26.636 degrees east. And the homework will sometimes you have you round it off to the nearest decimal or something like that, but that's how we have to write it. If we're told give a bearing, it needs to be written in bearing notation. So that's the problem. That's video 2. The video is just the one example of this navigation. Come on back and we'll discuss Heron's formula.